Okay, we have we did some questions for the past few weeks. Today we are going to back to our regular lecture. Let's recall the trigonometric functions that we learned a few weeks ago. Okay, I will start with Amy. Give me the first function.
Sine.
Okay, sine.
I'm goddamn back.
Okay, George, give me another trigonometric function.
Me?
Yes. So
Oh my
Amy
God.
said sine. Anything else?
Law of cosine.
Cosine.
Tangent, cotangent, cosecant,
O-
secant.
Okay, so
Tangent
we
of cosine
focus on
curve.
the first of four.
Oh.
To define these functions, we initially used these right triangles. A, B, C. And sine theta is the opposite side with BC over the hypotenuse. The hypotenuse will be AB. And the cosine, the adjacent side AC over the hypotenuse AB. The tangent sine over cosine. We can simplify, we get BC over AC. Then cotangent. In particular, it's 1 over tangent. Because cosine on the denominator, so for tangent to be well defined, cosine cannot be 0. This one, okay, for tangent. Mhm. Similarly, cotangent is over sine theta. Sine theta cannot be 0. It's defined when sine theta. Okay, let me redraw this. Okay. Later, we introduce the radian. So degrees to radians. We start with the whole circle. The whole circle in degrees, we have 360 degrees. And if we have the radius 1, the length of this will be 2 pi. Okay, so in certain sense, 360 degrees equals 2 pi. Okay, George, what is pi?
Pi is 180 degrees Celsius.
180. And
Oh, fucking hell.
Amy, what's pi over 2?
Um,
How do you compute this?
There's wait, I have a paper for it.
Okay, do not check your paper. Check my hint here. If pi is 180, what about power 2?
90.
Yes. You don't have to check your paper, you can just compute it. Aaron, power 3.
Whoa, okay. 60.
Okay. 60. And Kira, power 4. How do you find the power 4? Kira, I mute
30
you. Okay.
degrees?
So how do we find the power 4? Well,
Divide
if we
90 by
use
2.
this, power 2 is 90,
So that's, oh, so it's 45.
45. Yeah, yes.
就蹲着吃了。
What's that? Pi over 6. Aaron,
30.
30. Okay, so these are the frequently used radians. We use theta for degrees, we use x for radians. In this way, we will change the variable. Initially, it's sine theta, cosine theta, tangent, cotangent. We change theta to x.
Really quick. What would 1 degrees be?
Okay, good question. Let's check.
Oh my fucking God.
How do we find this?
You count the 362 pi divided by 360.
Yes.
That's gonna be pi over 180 degrees is 1 degrees, which is like cosine 1.
No, it's just this. We cannot simplify any further.
Okay.
Okay. What is 1? If the radian is 1, what's the degree? Any thought? Okay, someone sent me a message. Let me check out. Amy. Okay. Okay. Okay, Amy, any thought on this? What's the degree if the radian is 1?
I
Not
don't
easy?
really know.
Let's check. If pi is 180, how do you find 1? Previously, how do we find 1 degree? 1 degree, we divide both sides by
Okay.
180.
You divide 180 by pi.
Yes, so we divide both sides, okay, wrong line, by pi, we get the degree for radian 1. So in this way, we can go back and forth. For any degrees, we can find the radian. For any radian, we can find the degree. Okay. Now for the sine function, so x is all real numbers. Cosine x for all real numbers. However, for tangent, sine is not 0. So cosine is not 0. So,
Excuse me.
yes.
What's the sign behind the real numbers?
Okay. So this symbol.
Yeah.
So this we use this A. That means A is an element.
Oh, we never taught that sign. So
Okay, I'm glad you asked. So we use this to denote the fact that A is an element in the set. So here means X is the element of the real numbers, so X is a real number. This one we need. What do you call the domain? X not pi over 2, 3 pi over 2. Cotangent sine not 0. X cannot be 0. As pi. If we put them all together, so this will X cannot be integer pi as pi over 2. X cannot be integer multiple of pi. So K is an integer. Okay, these are the domains of the functions. For sine is defined for all real numbers. Cosine also all real numbers. However, tangent is defined as the quotient. So for this to be well defined, cosine the denominator cannot be 0. The cosine pi over 2 is 0. So X cannot be pi over 2. 3 pi over 2 is also 0. So X cannot be 3 pi over 2. You check this one by one, X cannot be integer multiple of pi plus pi over 2. Similarly, cotangent, sine cannot be 0. When X is 0, sine X is 0. So X cannot be 0. When X is pi, sine pi is also 0. So for this to be defined, X cannot be pi. You check this one by one, you can see X cannot be any integer multiple of pi. Okay. Next, let's recall the supplementary angles. Okay, George, can you give me the definition of supplementary angles? What are they?
Adds up to the 90 degrees. 80,
Double check? Double
180.
check?
Oh God, 180.
Okay. So previously we defined this two angles are supplementary if alpha plus beta. Okay, now we introduce the radian. We can also use radians. So this degrees.
wait, could you just say equals pi?
Yes. Okay, so two ways to see complementary angles. Supplementary. Either we say that summation is 180 degrees or it's pi using our conversion over there. Okay. This implies beta equal pi minus alpha. Okay, let's find the formulas of the trig functions for supplementary angles. Sine. Okay, I will give a minute to think about this. I will check with you the solutions. Jessica, think about it. What's the formula? I will start with you.
Wait, what am I finding the formula for?
Okay, so could we
Uh,
simplify this? Sine pi over x, pi minus x. Is this related to sine x, cosine x, and something else? So for supplementary angles, sine pi minus x. George, what's your answer?
For what? There's 4 questions.
Sine pi minus x.
That just sound beta.
I know. So this is
I forgot.
just sine x. Okay. Formula for supplementary angle. Sine pi minus x, just sine x. Why is this? Let's draw a circle.
Oh, supplementary angle damn thing.
Okay. Then this will be the supplementary angle. It's different color. Well, that's not a good way to see this. Maybe I should start with pi minus it. Go the other way. I start with pi minus theta, and then this one turns out to be theta. Now sine pi minus x. This is the y-coordinate of this point. The y-coordinate will be the height. This is sine theta. Okay, I use theta. I should use x. So the formulas for supplemented angles. I had to judge. Amy, next one. Cosine.
I think it's cosine x.
Cosine. Okay, let me.
Oh, this is the part where you explain like why sometimes it's negative cosine.
Okay. So Amy, he mentioned negative, positive and negative, Amy.
Quadrats. It's what we learned in algebra.
What?
Algebra 1, 2, 3, 4, the quadrant.
Oh, negative,
Okay, why is negative?
because it's in that side of the thing.
Okay, because for this one, the x coordinate is negative. Go that way, it will be negative cosine x. Okay, now we have sine and cosine. Jessica, about tangent.
um, um,
Okay, first, what's the definition of tangent? It's a quotient, right?
mhm.
So which over which?
Sine over cos.
Sine pi minus x, cosine pi minus x. Okay, Jessica, apply the previous formulas. Try to simplify this.
Sine x over negative cos x.
Okay. Which is?
Teacher, it's
Um,
supposed to be negative cosine.
George, is this what you mentioned?
Yeah.
Okay. Now if we
Yeah, no,
simplify,
I realize what I did.
it's a little bit. I asked Kira, your turn. What's the definition of cotangent?
Cosine over sine.
Cosine over sine. Can I simplify this?
Okay.
So that's
Kira.
negative cosine x over sine x. So that's negative cotangent x.
Okay, nice. So these are the formulas for supplementary angles. Next, we move to complementary angles. Okay, Aaron, what's the definition of complementary angles?
It's like when two angles add up to equal 2 pi in the
If
bracket.
pi is supplementary,
It's at 2 pi, like 360 degrees.
okay. So supplementary is pi over 2.
I believe
Complementary. I'm not sure what I said a second ago. I mean, complementary, the summation will be 90 degrees. 90 degrees is the same as pi over 2.
Oh wait, no, I said
In
in
particular,
reverse. Sorry, I said reverse.
okay, okay. Pi over 2 minus alpha. Okay, so we use this to represent a complementary angle. Okay, now the formulas. Think about it. We'll start with Aaron. Any idea what the first formula will be?
I believe it's sine x, I believe.
Still sine.
Mm-hmm.
Let's try to draw a right triangle.
Isn't that just a half circle?
You mean pi over 2?
Yeah, that's just
Pi over
half
2 is
circle.
the quarter circle.
That's
Half circle is pi.
pi over 2 is actually, yeah, god damn it.
Hmm. Suppose this is x. This will be the complementary. Okay, Aaron. Sine pi over 2 minus x. How do you find this sine?
From my look at wait, where?
Sine of this angle.
Oh, that's like AC over AB, right?
AC over AB.
For that triangle.
Now we check x. AC over AB. Is sine x or cosine x?
Oh wait, yeah, it's cosine. It's cosine.
Okay, okay. Now you see it's cosine.
I thought you were still referring to the other one.
Okay. Peter, can you hear us, Peter? The Fred? Turn the camera, Fred. Okay, back to George.
Yeah.
Cosine, complementary.
Okay. Complementary.
Mm-hmm.
Can you scroll up real quick? I want to get some inspiration.
No, that's not needed. That's
Can I
not
check
going to
my
help.
notes? Can I check my notes?
Okay, let's check it here. We have a triangle over there. What's cosine this angle?
Pi
Using
over.
three sides.
Let's just half of cosine that side. Let's just sine.
Okay, so
Negative
this is
sine x. That's negative sine x.
it's just a sine x
Why
because
not
this
negative? Oh, first
is
quadrant.
BC over AB.
This
Okay,
is.
next, Amy. How do you find the tangent complementary?
Um,
Wait, real quick, how do we get to the function that sine times pi over 2 minus x equals AC divided by BC? AB?
Okay, so we have a right triangle over here, right?
Yes. Sine is the BC.
So for this angle, what's the opposite side?
CA, right?
Yes, that's what I wrote.
AC divided by AB. That is
Yeah.
going to get sine. But, oh, cosine x is an angle?
Cosine
Yeah.
x in this
Yeah,
right
that makes sense.
triangle.
That makes sense.
Mm.
That makes sense.
So AC is the opposite side of this angle, but it's also the adjacent side of this angle. When the angle changes, the description also changes. Okay, back to Amy.
um,
Okay,
co
definition. What's the definition of tangent?
um, I think it's x divided. Wait, AC divided by BC, or maybe it's the opposite way.
Okay. It is the other way we can use this. Okay, sine over cosine. Can you simplify this quotient?
AC over BC, AC divided by BC over BC divided by AB.
Okay, so eventually we can use this and
Oh,
this.
right.
Uh-huh. What do you get?
Cosine x divided by sine x.
Which is,
Um,
what's the quotient?
uh,
Cosine over sine.
I think I'm missing something.
Cosine over tangent or cotangent?
What?
Tangent or cotangent?
I think I know.
I think I know.
I said first.
Okay,
I'm gonna say
okay.
that's cotangent. Try that.
Okay. Okay.
Okay, bro.
Oh yeah. Oh my God. Okay. I should have gotten that.
I know. Yes, it's not difficult. That's okay. That's okay. Sometimes we can just get stuck by easy stuff. And Jessica, next, last one.
Um, um,
How do we define cotangent?
um, wait, wait, I forgot.
It will be cosine over sine.
Oh yeah.
Okay, now let's simplify this.
Sine x over cos x.
Which is,
Um, um, BCA.
okay, use the trigonometric function.
I forgot it.
So sine over, okay, Amy, now you know, Amy.
Tangent.
Okay,
Tangent. Yeah.
okay. So these are the formulas for complementary angles. you can compare it with supplementary. For supplementary angles, sine stay the same, cosine with opposite sign. Tangent and cotangent, they all opposite sign. But sine stay sine, cosine stay cosine. For complement angles, we switch. Sine go to cosine, cosine go to sine. Tangent go to cotangent, cotangent go to tangent. Okay, the differences. Okay. Next, we want to graph these functions. We start with okay. Do it first. George, remove that.
Wait, we're making an XY graph?
Uh-huh.
Okay, over sine and cosine. I think I've seen this
That's a
before.
cosine and sine curve thingy, bro.
Okay.
It literally goes like a snake.
I think it, I think we talked about this like a few classes earlier. And why is my
Yes, but three weeks earlier.
I don't know why my glasses are still here.
Okay.
Bro, just delete them.
I guess God wants me to keep them.
So we find the values.
Great.
We
Goodbye.
first try to graph this sine function.
I don't like sine functions.
And
Okay,
now it
it's
looks
fine.
like a squiggly line.
Uh-huh. Okay.
It's more like
So
a
we
S
know that
shape.
when x is 0,
This is fun as hell.
sine 0 is also 0. X power 2, sine is 1. X
Cotangent?
pi.
No. Teacher, tangent 0 is undefined, correct?
Okay, we will be there. Give me a few seconds.
They're both undefined, I think.
Think about it, and then you check. Let's check later.
Wouldn't both be undefined because you either one like
No, it's
Like,
how else
no.
weird. You should wait.
the cotangent? No, wait. Never mind.
Okay. Think about it.
That's
We
how
will
else
be
weird.
there.
If you think about
So
it.
I'm going to mark these points. Then I connected them. Get a graph. It's too bad. Okay. You should be careful. This is not half circle. Can you tell me why this is not a circle? Not part of a half
Radius
circle.
problem?
What's that?
It's a radius problem.
Okay, you're getting close.
Well,
Because
it's distance at the top point and like the other point of the circle is different.
Like
Like
because this
That's what I meant by radius problem.
from pi
oh
to
yeah,
2
Kira.
is from the pi over 2 to the 1 is less than the is different from the pi over 2 to the pi.
Okay. So
And from pi
because
to 0 to the 0.
pi approximately, so pi over 2 approximately,
1.57. And 1.57 is not equal to 1.
yeah, that's the key point. So this is 1, but this is 1.57 something. So now you know this part cannot be the half circle. this cannot be a half circle because the measures are different.
Measures are different.
Okay, so this is sine. Next, we want to do cosine. Do the same thing. Do the same thing. Oh, remove this. Easy graphing. Okay. Let's try. Where did I stop the next? Okay, maybe it's Kira. It's your turn. Cosine 0. Do you know this value?
Cosine 0 is 1.
Okay, nice. Okay. And Aaron, are you ready?
Huh?
Okay. Are you ready, Aaron?
Oh, yes.
Cosine pi over
Cosine
2.
0. That's
Okay,
0.
nice. Nice. Nice.
Uh,
George,
It's not 0.
cosine pi.
What? That's just cosine 180 degrees.
Which is?
0.
What's that?
That's 0.
0 is pi over 2.
Undefined. No.
No.
I
Wait,
can
cosine
answer. I
0
can
pi
answer.
1.
Give me a second. What's that?
1?
Okay, let's go back to our formula. Cosine pi minus x, negative cosine x.
Negative
Can you
1?
Okay. We will apply that formula, we get negative 1.
Yep.
Then this will be Amy, 3 pi over 2.
3.
Negative 1. Wait, no. Oh, that one. Okay. I thought it was okay, yeah. 1. Wait, no. Uh, uh, uh,
Not 1, not negative 1.
Um, wait a second. Can I say?
wait, I'm trying to
Okay.
graph it.
Okay. Yes, you can graph this. Okay, Aaron.
I think it's 0 because accordingly to the graph perception.
Okay. And Kira, 2 pi.
Wait, that would be. I do not know.
Mm-hmm.
Negative? No. 1?
Okay. We can apply the formula twice. Now you see the pattern. What's the pattern over here?
It just goes opposite to the sine x. Like whenever sine's 0, then that's like cosine's 1, and then it's kind of the opposite.
So it's oscillate between 1 and negative 1.
Uh-huh.
So if we arrive at a 1, we have to back to 0 before we can get a negative 1. If we are at negative 1, we have to go through 0 to get 1. Okay, it oscillates. Okay, let's mark the points. X0, y equals 1. X pi over 2, this is 0. X pi is negative 1. 3 over 2. Again, these are not circular arcs. And you should know why they're not circular arcs. Okay. Next one, tangent. I will start with a final 0 pi over 4 pi over 3 pi over 2. Okay, some of the not easy. Let's start with the easy one. Jessica, if x is 0, what's tangent?
0.
0. Okay. And Aaron, if x is pi over 4, what's tangent pi over 4?
That's like tangent 45 degrees, but I forget which one is that.
Okay, okay.
Yeah, I got this one.
Uh-huh.
Oh, 1.
1. Okay. And George,
Yes.
tangent pi over 3.
Meh. I mean, same thing, right?
What do you mean same thing?
0 divided by 1 is undefined.
What's that?
That's, wait, correct me if I'm wrong. Undefined?
No, no.
I'm not my brain's not working with this real quick. Let me
Uh-huh.
Wait,
Okay, Aaron wants to
this is
try.
is it like a root?
Rule something.
Oh, I got this.
I don't know. I forgot.
I'm guessing, but root 3.
Oh, okay, Kira.
Wait,
Root
do I
3
have to
over
remember this?
2?
Because I don't. I can't remember this.
Wait, is it root 3?
It's root 3 over 2, yeah.
Huh?
How do you
Rule
guys
3
get
over 2
Can someone
is
help me real quick? I don't
sine.
know how you get that.
Oh, never mind.
Not okay.
Well, then that's root 3 over 2
Oh,
over
root 3 then. Fine, root 3,
something.
root 3.
Okay, why? Okay, let me give more steps. So this is
Hmm.
this.
Oh yeah. Wait, everything's coming back now. I remember now.
Oh, I think I can recall something. Do we have to remember this? Because I do not.
Yes,
I do
you
not
Wait,
remember.
so
and
that's
you
like
will.
I don't remember this.
2 root 3 over 2, and that basically is just root 3.
Mm-hmm.
And then for root 2, that's like tangent 90, which I believe does not exist because it's 90.
Tangent 90 does exist, correction, but it's just how that's weird.
Hmm?
That's
I think it's
not
undefined.
defined.
It's
No,
like
no, no.
undefined.
1 over 0 is undefined, I believe.
Okay,
Yeah,
undefined. So
that's what I
doesn't
meant. So
exist.
that's what I meant when I said undefined.
Mm-hmm.
Well, root 3 is not undefined.
Okay, this one I will let you check this after class. Okay, now let's try to
Wait, what
graph
about
this.
cotangent? I'm curious.
Okay, we'll do that later.
Okay.
Mm.
To take it. Um, it's better now. Okay.
Oh, yes, yes, yes. I think I'm remembering something. Can
Wait,
we do a review on this some days? Because I don't remember this.
This is review.
Wait, hold on. Wait, I have a question. Is the graph like according to my notes, a long stick going up
Uh-huh.
and
So
then going down, then going up?
when x when
Uh-huh.
x is 0, when at 0, x power 4 is at 1, power 3 root of 3.
And
Then
then
that
power two
goes
does not exist. And then like goes back down to like down there and then it goes back up again. Is that right?
okay. So we start with 2 pi over 3 somewhere over there, negative square root of 3. Pi over there, negative 1, 0.
So I get these things by dividing the sides. That's corresponding to the fraction. Correct?
Okay.
Wait, teacher, can you remind me like one final time how I get these values?
Uh, how do you get a sine or cosine?
Yeah, because I know how to get sine or cosine, but you divide the set, but how do you like do it like when you get a certain angle, you know?
Yes. So, okay, let me give you some simple review. If we have a right triangle
Mm-hmm.
with 45 degrees, what's this side?
45 degrees.
Also 45. Two angles, both 45. What can we say about this triangle?
It's an equilateral. Quadrilateral. How do you
Isosceles.
Isosceles.
isosceles?
Isosceles. So, okay, if this is 1, how do you find this side?
I forgot, honestly.
We don't know.
Oh,
We don't know.
that
Let's
is one.
say,
I don't know the other sides. I don't know how to.
okay, let's assume they are both x because isosceles.
Yeah, yeah.
Oops.
You killed the triangle, but
Yes, I get it back.
together. But
X. Then we have the Pythagorean theorem. X squared plus x squared equals 1 square. Okay, Judge, how do you find x?
mm, x is just a one divide. Let me think about this. One minus x.
So
No,
this will be
the
2.
square. Yeah, because the square root of one is still one, and one minus x.
Oh I know, isn't it 1/2? And then you root it.
No, the square root of one. So
Huh?
2x squared plus
But then you
1.
have to root 2 as well.
No, 2x squared plus 1 equals 1. X squared equals a half. Yes?
Oh well, yeah,
Um,
that's right.
so, but, what if it's, say it was like 30/60 and then it's not an equilateral? How do we get it?
Okay, this is the first one. Next, let's do the second one.
Wait, first what?
First, special angle, power 4.
Aha.
Mm, Second one. Okay, so for this one, I'm going to connect the midpoint. Okay, let's recall a theorem about the median of a right triangle. What can we say about this median?
It's a median.
It bisects 90
Equals
degree.
Okay,
it
Amy.
it makes two isosceles triangles.
Okay, so the theorem, yes, the theorem is that CD is half of AB. So CD is AD and BD. So that's the
Oh, midpoint.
theorem.
Wait, do I have to prove this?
It's
Because
the midpoint theorem.
I believe so. Because I have to
It's the
put.
isosceles triangle thingy.
Okay, so for this triangle, we have CD equals BD. Okay, George, what can you say about this angle?
Mm, it's an angle bisector.
What do you mean?
Uh, it just creates two. It splits to 90 degrees.
Okay, so let me try that again. We know that CD equals BD. What does this tell you?
CD equals
CD
one half
equals
of
BD.
AB.
What about this angle?
That's 90 degrees. That's gonna be 90 degrees.
Huh?
This angle.
Oh, it's 45.
Okay, try that again. We have CD equals BD. What does that mean?
It's an isosceles triangle, so like that degrees is 60 degrees, and then you can prove that CAD and CDB are all isosceles triangles.
What about this one?
They're both isosceles because one creates 60 degrees and one creates a 30 degrees.
George, I'm asking this one.
Oh, that's just 60 plus 60. That's just 160 degrees too. So that's actually an equilateral.
Okay, so this is also 60.
But so how do
So,
we no okay, I think I remembered how to do this, but apparently how do we find the value of like sine and cosine for like each specific angle measurement?
okay, this is what I'm doing.
Yeah, do we just remember it?
No, no, you remember how we found it? Do you
Oh,
remember this? How do you find this one?
yeah, but like how do we find it like that fast?
Do it many times.
Sure. So, but if in college, like I get a question that just tells me to find sine and cosine. Like it just tells me to find like 2 pi over 3 real fast and let me find the tangent. There's gonna be a quicker way to do it, right?
I mean,
Okay,
eventually you're gonna memorize it if you like know how to do it and you
I
do a lot of these problems, you're gonna remember like all the different points.
True. It's the
Uh-huh.
same. I think I eventually memorize the quadratic formula.
okay. So what this means, not only we have CD equals BD, BD also equals BC. That's the key point. So
Hmm.
BC is also BD, which is half of AB. From there, let's see what is cosine 60. George,
Cosine 60 would
uh-huh.
be,
Cosine this angle.
I forgot, sorry.
Formula. Which side over which side?
That would be the AC over CB.
Cosine or sine?
Oh, it's not sine. It would be AB over AC.
Okay, using the result here, BC is half AB.
Yes. So that would just be half AB divided by AB. That's just gonna be like 1 over 2. That's just gonna be a half.
This is how we find that cosine
Oh,
half 3 is
hey.
1/2.
Oh, so we found the ratio kind of.
Mm.
So we kind of do it by finding the ratio.
Uh-huh. Mhm.
Okay.
Yes. Okay, now how do we find the sine?
Oh, just AB divided by BC, which and we can prove that AB is also like 2 times BC, which is AB is also I think 2 times no AB divided by AC.
Okay, so here we use the Pythagorean theorem.
But
What's the
then we
summation
can
of the
just use the
square?
Pythagorean theorem to get that a
Equals
fourth
1.
a fourth plus something equals 1. And we could know that a fourth plus 3 over 4 equals 1, and we square root 3 over 4, and then we get 3 over 2? I don't know. What's the square root of 3 over 4?
3/4? That's like root 3/2.
Root 2, 2. No, square root of 3 over 4.
I believe that would match to, hold on, yeah, sine.
Yeah, that's
Okay,
square root of 3 over 2.
Like
this is how we find the cosine and sine of pi over 3. We use the property that this is half of the hypotenuse.
So we're basically we just kind of like redo this ourselves, and then we
Mhm.
remember, and then we can calculate pi at different angles, and then we use the tangent cotangent formula, and then we use like cotangent is sine over cosine, tangent is
Uh-huh.
vice versa.
Yes, yes.
Tangent is tangent is sine over cosine, cotangent is cosine over sine,
Uh-huh.
and then we just calculate numbers.
Yes, yes.
My math teacher told me that sometimes reading is easier than math. I laughed at her for that, and now I just think reading is easier than math.
Okay, so let's have 5 minutes break and we will be back at 32.
Okay,
Okay,
bye.
okay, okay. So next we will go to chapter 6
He's gonna be fluent. Right.
about geometry and algebra.
I thought sine and cosine had like algebra than no more algebra than comfortable. Like I still can't relate why the hell we need like a grid in like real life world and why would it affect number values? It's just so
Okay,
complicated.
Oh,
okay.
geometry is used in buildings and all that good stuff.
I
Like,
Okay,
know.
it's
My
used
father always
everywhere.
teases
You're
me about
just too
that.
young to understand this.
Actually, I
You
think I understand. Algebra was created for geometry. Yes. At least the line group.
okay? So we introduce notation vectors. Okay, who else seen this before? Vectors.
Vector is like the antagonist in Despicable Me.
Okay, okay, stop, George.
that's
That's not
just kind of
meaningful.
movie, like, not the
I'm not
actual,
wrong,
like,
okay? First of all, I'm not
Okay,
wrong.
Amy.
I know the physics meaning.
Okay, okay. So
I
it
think it's
means
like a
that,
displacement or something.
okay, so we have 2 points that
Displacement.
move from A to B.
And then you have to count how much they
Is this
move
like
according to the
the
shape.
velocity where everything's moving?
Okay, velocity will be another vector. Yes,
Does
Kira.
it show like the uh wait, hang on. Like
Yes.
the direction. I know like in physics is like the direction it's moving and the speed it's moving at
Yeah,
the same time.
Okay,
so
okay,
What about
okay.
that?
it's like vectors are a physics quantity that has a direction and then magnitude is
Magnitude.
basically,
Okay.
no,
Okay,
not
very
magnitude,
nice.
scalars. Scalars are basically physics quantities without direction, like time. So that would be a scalar. Yeah.
Okay, very nice. So a vector is a quantity that has a direction and magnitude. Two vectors, if they have the different magnitude, so we have one vector here, one vector there, they have the same direction, but a different magnitude. So the different vectors. We also use, okay, notations. Sometimes we use this A, B, we put an arrow on top of it to indicate this is the displacement from A to B.
I don't
Okay,
like displacement. Can you
okay,
explain
okay.
that again?
Okay. So it's the movement from A to B.
That's the displacement?
Uh-huh.
What the physics
Okay.
nonsense is this?
Okay, George, stop
It's actually
that.
pretty useful if you actually pay attention.
I don't think that's gonna help me make any money.
Then stop yapping about it.
Exactly. Why should I be putting sunglasses in a Zoom meeting?
Why wouldn't you? What's wrong with your life if you don't do that?
Okay,
Whoa
George, stop
there.
that. George, Aaron, stop that.
Serious question.
George, stop that. Okay, so two vectors, if we have a different magnitude, they're different, have different directions. Okay, one goes there, one goes there. Same magnitude, but the different directions, also different vectors. Okay, now two vectors. A, B, P, Q. We have this A, B, P, and Q. If they have the same direction and the same magnitude, then the two vectors are equal.
Same direction and same magnitude.
Yes,
Another house vocab.
and same. Even though these two are at different places, still they are equal vectors. Because the vectors only depend on directions and the magnitudes. It doesn't depend on where the vector is. Yes, Kira.
So like the u vector and the v vector above like are not the same because the magnitude is different.
What are these
Because
vector
the
Wait,
anyway?
I have a
magnitude are
question.
different. Yes,
So
Aaron.
is A like a XY point? Is this what we're gonna do in geometry and algebra?
Okay, so vectors, they are in all kinds of dimensions, two-dimensional, three-dimensional, maybe four-dimensional.
Is
So
there a fifth dimension?
uh, there'll be no vector over there.
So there's only up, down, left, right.
For 2D graph.
Okay, so
I mean, I don't want. There is a 3D graph.
But like, yeah, but
I
we're
don't
not
think
gonna
you want to use it, goddamn bitch.
okay, George, stop that.
Oh my bro, Jordan. That's just
Okay,
kind of
okay. So if we have 2 points, we can find their coordinates.
Vector. Yeah.
what?
Now we consider the vector.
Do we know how to find a vector? Because we only know how to like tell if they have the same vector.
So this time we move from P to Q. The change in the x coordinate will be C minus A. The change in the y coordinate will be D minus B. So we have a
Is it
second
okay if it's
formulation.
if it's okay? Is it okay if it's like D minus B? No, B minus D instead.
So we can use the components. C minus A, D minus B. Okay, so George asked, could we write
Yeah,
A
because
minus C? Could we use B minus D? Does this work?
you remember the midpoint theorem?
So C minus A will start at A, end at C. So end minus start. If A minus C, A is the end, C is the start, it will be this vector.
I don't
I
like
will
that.
different color. Okay, so this is Q, P. You can see the difference of this. which one is the starting point? Which one is the ending point?
Oh, so like the farther it is in the x-axis, that's what we use.
And so it depends. So which direction you are going to?
Oh, yeah.
Uh,
So but if we're finding the vector towards the left, we'd use what I said, but if we're finding it like towards the right, we're using like that.
okay, so let's have some exercise.
Okay. Bro. I wish the class was kind of longer because it's only 20 minutes left.
Oh wait, by the way, you know who Zisheng is?
Is he Shang fan?
Yeah, I think no, Zisheng.
That's him. All right.
Oh, she said you're weird.
Okay, George, stop that.
Huh? Oh yeah, that's because he has some
Yeah,
beef
I
with his
know. He
friend.
always crushes that.
Okay, Aaron and George, mute yourself.
Uh,
Okay.
Wait, teacher, what's a vector in Chinese?
Okay, we'll do that later.
Oh.
This will be 2, 4, 1, 3, 3, 5. 0, 1, 1, 5. Okay, approximate. We have several vectors.
Couldn't we say A, B, C, and D, and E, I think?
Okay, we're good. Let me finish this, then I will label the points. I call this
Is
A,
there like is there like a certain name for each direction?
C, D, E. Okay, let's find the vector AB.
Let's see.
You use 3
Enter
minus
your answer in the chat. Okay, enter your answer in the chat.
um,
AB. So use this bracket. Use this bracket for vector. You can see the difference. For points, I use parentheses. For vectors, I use bracket. It's the difference between points and bracket. One, one. Okay, so as Kira, which one is 1, 1? Which vector is 1, 1?
AB.
AB is 1, 1. Okay. How do you find this?
3 minus 2 and 5 minus 4.
Okay. Okay. And Amy, AC.
AC is 2 minus 1 and 4 minus 3.
Okay. So which is the starting point?
Oh, okay.
Ah,
1 minus 2 and then 3 minus 4.
right. So be careful where we start and where we finish. And Jessica, AD.
Oh,
wait, teacher, remember the midpoint theorem thing?
Okay, stop that. Stop
That's
that.
for triangles.
Yeah, it's
AD,
just
J-
like,
Jessica.
um,
So we start
Um,
at A, and at D.
uh, wait,
It will be a difference 0 minus 2, 1 minus 4.
2, 3.
So the other directions, -2, -3. And okay, Kira, last one, AE.
Wait, -1, 3.
Wait,
How do you get a
isn't it-
-1?
The 4 minus the 5.
wait, no,
Oh
isn't
no,
it?
it's the 5 minus the 4. Sorry, 1 and -3.
How do you get a 1?
Isn't it, since it's A to E, isn't it the 5 minus the 4? Or is that a negative?
5. That's the second coordinate. Second coordinate, 5 minus 4 is 1.
Oh,
What's the first
it's
coordinate?
-3, 1.
-3 and then 1. Okay.
Okay, -3. Okay, so some vectors. Next, we will do vector addition. Okay, we have two vectors. We will use lowercase u and the v. We want to define a new vector. Okay, define a new vector u plus v. To do this, there are different ways to do it. One way is we move or we make a copy of this vector at the end of v. I will make a copy of this. Let me see if I can make a copy. Okay, nice. So this is also u. Then the summation will be, we use the free starting point, free ending point. Okay, this is called the triangle method. Okay, then in coordinate, suppose u is a vector with two components. V is another vector, two components. Then the vector addition, we just add their corresponding components. Okay. E first coordinate,
So are we saying
second.
that we can add vectors?
Isn't that like?
Yes,
Oh yeah,
we
right.
get a new vector.
That is weird.
How the?
Okay, Aaron, what's that?
I was just gonna say what you were gonna say.
Okay. So given two vectors u and v, we make a copy of u, we connect starting point and end point, we get a new vector, we call it the addition.
Wait, what's the new vector again? Oh, you mean
The-
that? Ah, I see.
Okay. Then for vector addition, we have the commutative rule, and associative rule. The same rules we had for regular additions.
But what does that mean? Isn't
Okay,
like
what
A
does this mean?
not
Why?
just A plus B equals B plus A?
Exactly, yes. So this follows from the addition of numbers.
Oh, I don't like addition. Wait, is this
Okay,
why we learned addition in the first place?
okay. So the next one, we have three vectors. If we can add UV first, or we can add VW first.
All of them are fine.
Okay, the rules is the same. So this one, commutative rule. Doesn't matter which goes first. The associative rule. Doesn't matter which way two add first. Eventually we get the same. To check this is the commutative rule and the associative rule for numbers.
Wait, wasn't there a third one?
Third one will come later.
Okay, but like, wait, so if associative rule were multiplication, then that just wouldn't exist. I see.
Okay. So the next one we call scalar product.
Scalar?
The one without the
Direction.
direction, yeah.
Okay. So previously we have this number. Now we call it scalar to emphasize has no direction.
So is it just like a point on the graph?
Real numbers.
Aha.
1, 2, 3, 4, 1.5, pi, they're all number scalars.
So what's not a real number? Like root 2?
Root 2 is also a real number.
I doesn't work, right?
Okay.
Wait,
So
isn't I like negative root 1 or something?
Yeah, so that's an unreal number.
I believe so,
Yeah, but
because
we know how to graph a negative an unreal number on the graph, although it's kind of like cheating.
we define the scalar product. So it will be a scalar and a vector.
well, you could just write C as the all real numbers times something.
Sometimes, yes.
Okay. C A. Okay, that's what Aaron wants. The scalar multiplication we just multiply C with each component.
Aha. But wait, hold on. Oh yeah, that makes sense.
Okay. Let's check. Let's check. V add V. Okay, if this is our vector, what's V plus V?
That's 2A, 2B, I think.
There will be A plus A, B plus B, which is 2A to B.
Yes, yes. That's
Or
because we
this
just
will be 2V. The scalar will be 2 times A,
it's like the
2 times
enlargement
B.
thing.
It's the
Like,
same as 2A to B.
oh, oh yes, yes.
Okay, so we can use addition or scale multiplication. In these two cases, we get the same answer. Okay. With this, we can define negative v.
Isn't that like negative a, negative v, or something like that?
It will be, we just replace c by -1.
Well, okay, yeah.
Now we can define the subtraction. U subtract v. How do we do subtraction?
Same way as we did the multiplication.
Okay.
Wait, what's u? CD or
Okay, u, let's see.
But if
C.
u subtracted by negative v would just be plus. I think we just do I think we just do addition instead, don't
oh,
we?
it's u plus negative v, I
I think
think.
we just use. Yeah. Why can't we use like u minus negative? Why can't we use u minus v?
Well, because right now it's u plus negative v, which is
Yeah, but like I know like what it means, but I don't know like I know what it means, but why do we have to write it this way?
well, I think it's some kind of theorem.
Oh,
Okay. This is how we do the vector subtraction.
I guess this is
It
why.
turns out to be just the difference of the coordinates. So we can add, subtract vectors as we have done for numbers. At this moment, you may think the vectors, they're just like numbers. But the next time we will learn something new, see that the vectors are completely different from
Oh,
the numbers.
I
That's
just
something
wish we
very,
learned simpler stuff.
We
Okay.
will learn something new and very useful. Okay.
why am I suddenly afraid of next week?
I'm always afraid of my next week. It's fine, bro. It's completely fine.
Uh,
Okay.
these weeks have always been pretty cool.
Yeah, math is cool. You have bragging rights on intelligence.